All right, now that we're familiar with the Pythagorean theorem and its converse, let's do a few examples that use all these ideas. Here's a triple of numbers. Let's decide if these numbers could be the lengths of the sides of a right triangle. So first thing we should do is to see which of these side lengths is the longest, and that would be the one that might be the hypotenuse. So here I'd have 85 as the hypotenuse and 51 and 68 as the two legs. So we'd have to just compare 51 squared plus 68 squared, and let's see if that's equal to 85 squared. So I would just check that on my calculator. 51 squared plus 68 squared is 7225, and 85 squared is also 7225. So the answer is yes. So these would be the lengths of a triangle, and the triangle would be a right triangle. Let's take a look at this one, 2, 3, and the square root of 13. So before I figure out how to put these into an equation, I should decide which of these numbers is the largest. And to do that, maybe you know this or maybe not, the square root of 13, what is that approximately? Well, 3 squared is 9, 4 squared is 16, so the square root of 13 is somewhere in between 3 and 4. So this would be my longest side. So let's go ahead and write these. This is what the triangle might look like. And let's decide if 2 squared plus 3 squared is equal to the square root of 13 squared. So that's a question. 2 squared plus, this is 4 plus 9, this is 13. And the square root of 13 squared is also 13. So my answer here is yes. These could be the lengths of a right triangle. Again, I'm just validating or verifying the Pythagorean theorem here. And last, 3, 4, and 7. So I'm going to check this, but I have a feeling that the answer is no. And here is why. The triangle inequality tells us that the sum of the two sides of a triangle need to be greater than the third side of a triangle. And here, 3 plus 4 is equal to 7. So I have a feeling that this is not going to give me any triangle at all, actually. But let's go ahead and verify just check by plugging these numbers into the Pythagorean equation. 3 squared plus 4 squared, see what we get, and if that's equal to 7 squared. 3 squared is 9 plus 4 squared is 16, so we get 25. And let's see if that's equal to 7 squared, which is 49. So my answer is definitely no, but I do want to say it's not even a triangle by the triangle inequality. In fact, if I had side length 3 and another side length 4 together, those actually make 7. So this couldn't even form a triangle if you tried. All right, so now let's take these ideas and use the ideas of Pythagoras to develop the distance formula in the plane. So suppose you have 2 points, A and B, and their coordinates. You have an x coordinate and a y coordinate, x1, y1, and x2, y2. Then draw the line connecting those 2 points here. And you want to say that the distance between these 2 points is the length of this line segment. And now you can complete this triangle here. And what we have is a right triangle. And the base of this, one of the legs of this right triangle, it's between this point A and this point C, which are on the same height. So they are going to have the same y coordinate, and their x coordinates are different. A has the x coordinate x1, and C has the same x coordinate, the same x location as B, so that's x2. So the distance here, this length, is the distance between those 2 points on the number line. Here's x1, here's x2. So this length here, this length is x2 minus x1 in absolute value. because you want to make sure that you don't accidentally subtract in the wrong order and get a negative distance or something. And then this length, the other side of the triangle, the other leg, is the distance between the two y coordinates, y2 minus y1 in absolute values. So now let's go ahead and just label these things. Let me call this side A and this side B and this side C. The Pythagorean theorem says that a squared plus b squared equals c squared. So now A is the same as y2 minus y1, right? y2 minus y1 squared plus b is the same as x2 minus x1 squared, and that's equal to c squared. And remember that c was what we wanted to use for the distance between the 2 points. So now I can solve for that distance by taking the square root of both sides. So the square root of what's on the inside, and actually just to make it look pretty, I'll write the x's first. x2 minus x1 squared plus y2 minus y1 squared. That is equal to c, which is the distance from point A, which had coordinates x1, y1, to B, which had coordinates x2, y2. So this is the formula that you might recognize from maybe high school or late middle school, telling you how to calculate the distance between 2 points in the plane. So let's take those ideas and apply it with some numbers. And this might require us to do some graphing. So something I want to point out, I think I had a typo in my original notes that were posted. So I had to redo them. This number here should be -5. So if you have that, it's something different. Please change it. All right, so what I want to do is show that these coordinate pairs, 7, 4, -2, 1, and 10, -5 are the vertices of an isosceles triangle. So basically, here's just a rough sketch of what's happening. If you have the point A is 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, so 7 units to the right, 4 units up. Here's A. B is 2 units to the left and 1 unit up. Here is B. And C is 10 units to the right and 5 units down. 1, 2, 3, 4, 5. So here is C. So what we want to do here is show that not only is this an isosceles triangle, meaning that the length from B to A is the same as the length from A to C, but it's also an isosceles right triangle, so that this side squared plus this side squared should equal the hypotenuse squared. All right, so let's go ahead and do those calculations. First, I'll have to calculate the distance from A to B here, which you can get by doing the square root of the difference between the x coordinates. So there's -2 minus 7 squared plus the difference between the y coordinates, 1 minus 4 squared. So -2 minus 7, what is that? -9 square it, you get 81, plus 1 minus 4 is -3 square it, you get 9. So that is the square root of 90. That's this side length here. Now let's do AC. So the distance from point A to point C. Calculate the square root, subtract the x coordinates, 10 minus 7 squared, plus subtract the y coordinates, -5 minus 4 squared. 10 minus 7 is 3. Square it, you get 9. Plus -5 minus 4 is -9. Square that, you get 81. So again, I've got the square root of 90. So already I know this is an isosceles triangle because these two lengths are the same. So yep, an isosceles triangle. Now I need to find the length of the hypotenuse and then verify the Pythagorean equation. So let's calculate BC here. That distance will be from B to C. Subtract the x coordinates. So 10 minus negative 2, or 10 plus 2 squared, plus negative 5 minus 1 squared. So this is 12 squared, which is 144, plus negative 6 squared, which is 36. Negative 6 squared is positive 36. And when you add those together, we get the square root of 180. All right, so now let's verify the Pythagorean identity, which is the square root of 90 squared plus the square root of 90 squared. Let's see if that's equal to the square root of 180 squared. And indeed, 90 plus 90 does equal 180. So A, B, and C are the vertices of an isosceles right triangle. So again, that was using the distance formula. And there's one more application that we want to talk about, and that is the distance formula gives rise to the equation of a circle. And we've discussed what a circle was before. A circle is the set of all points that are distance, a given distance, let's say distance r, away from the center. And the center should have some coordinates like x or h. H and k is usually what we use for the center of a circle. So for instance, if you have a circle centered at the origin, then the circle will be the set of all points where the distance from the origin to the point x comma y satisfies that distance x minus 0 squared plus y minus 0 squared is exactly equal to r squared. So the distance is exactly r. And from this, we can imagine having a circle that is centered anywhere else in the plane, say at some point h comma k. The circle of radius r centered at h comma k would be the set of all points x comma y, where the distance from this point to this point is exactly equal to r. So squaring both sides of the distance formula, we have x minus h squared, so the difference between the x coordinates squared, plus y minus k squared, so that's the difference between the y coordinates, is exactly equal to r squared, where h and k are the center, that are the x and y coordinates for the center of your circle. So you'll have a few homework problems which allow you to kind of unpack these formulas and use them with actual numbers in context.